Let's go to the first question. I stream for 60 FPS. I'm not sure if it looks like 60 FPS on your side. Right. No, we have that. We have a UG general for UD people. We have that. We already have it. You just have to have the undergraduate role, and you can see it. Right. So first question. The curve C has polar equation, that guy, for theta ranging from 0 to alpha. Given that the length of C is S, find alpha in terms of S. Well, of course, when you see the length of S, it just means the arc length of this curve. But this is in polar form. So that means there are two ways to do it. It's either you do by not Cartesian, but parametric, or by polar itself. And it's easier to just do it from polar, actually. So just to recall, the formula is from theta 1 to theta 2. This is for polar, okay? So square root of r squared plus theta squared. Hope I'm not mistaken. Yeah, should be. Okay. Yeah. Oops. So many tabs. Yeah, it's kind of like a spiral, actually. All right, so let's do it. So we have S is equal to, it ranges from 0 to, oh, right. Oops, sorry. Oops. Yeah, that's why I feel like something is wrong. Okay, thank you. Yeah, like that. dr d theta. In my notes, we use this, but it doesn't matter. Yeah. Thanks for the reminder. Thank you. Mistake. In place of theta? Wait, I forgot. Wait, I'm sorry, I forgot. R squared plus dr d theta. Like this, right? Okay, sorry. Forgot about it. Okay, thank you. Okay, from 0 to alpha, square root. Well, r squared is you just square it. It's easy. It's also easier to teach A2 for your math students because I don't need to explain the little details anymore. You guys are for math students. You guys should know. Okay, and then we have the derivative, 3/4 and 3/4 theta, and you square it. We're doing polar, so we don't use dy dx. When do we plus 1? Is it for dy? Yeah, for dy dx, we have to plus 1. For Cartesian, we have square root of 1 plus dy dx. Like that. For Cartesian, actually, in general, you just have to remember this. This is all you have to remember. And then, in whichever variable you integrate in, you factor that out. Let's say you want to integrate in x, then you just factor the dx out. Dx 1 plus dy dx square. You just put this around here. Okay. Right. So let's solve it. 0 to alpha. Simplifying it, we actually can factor, because you see when you square this one, you get 3/2 again. So we can factor out the e power 3/2 theta outside, so you have 3/4 theta. 1 plus 9/16. Okay. So 1 plus 9/16. We have 25/16, right? Yeah, 25. This is 25/16. Square it, you get 5/4. Pull it out. And then done. You guys should know how to integrate this, right? Don't tell me you don't know. You squared the 3/4. Yeah, it was from 3/2, and then you square it, so it becomes 3/4. There. Okay. Yeah. Okay. Just normal integration here. Actually, I can cancel the 4. So let's do that. 5/3. Putting alpha in. We have 3/4 alpha. Minus, well, when theta is 0, then you have a power 0. So you have a e power 0, which is 1. So minus 1. And remember that this is given to be equal to s. right? Sorry, S right here. So this is equal to S. And now we have to find alpha in terms of S. So basically just making alpha the subject. Let's do that. Actually, yeah, I mean, you guys can do it, but let's just do it together. Multiply both sides by 3 by 5. Minus 1, 3 by 5s. Plus 1 to both sides. I'll just make it fast. Take the len, multiply by 4 by 3, and you get the alpha. Right? Should be fine, right? Yeah, okay. Any questions for this question? No? Okay. If you have any questions, just go on and ask. No problem, as always. Right, for number 2, starting from the definitions of hyperbolic cosine and hyperbolic sine in terms of exponentials, prove that this equation is true. Basically, you just have to prove from that the left-hand side is equal to the right-hand side for any x. Let's start from the left-hand side, actually. So hyperbolic cosine 2x, by definition, it'll be e power 2x plus e power minus 2x, right? All over 2. Basically just changing this x into 2x. And now, you need to find a square somehow. But you see that these two guys are squares. Why not just complete the square in this case? Yeah, right-hand side to left-hand side is easier, but it's not fun. Let's do it left-hand side to right-hand side. So you just have to complete the square. So you have e power x and then e power minus x here. But you want a sign. If you want to have a hyperbolic sign, that means you want to have a minus inside this guy. You're going to put a minus here, and you put a square. But remember, when you square it, there's an extra term of minus 2. So you have to add 2 to it back. So that stays the same. That's all over 2. Okay? And now from here, you can just split the fraction. If you split the fraction, you'll get this guy. All over 2 plus 1. But we want to find a hyperbolic sign somehow. So we want to have a 4 here so that it goes in the square, it becomes 2. So you can put the hyperbolic sign definition. But then don't forget to multiply by 2. And so that's how it became like this. All right. Okay, 3 marks. All right. Find the set of values of k for which hyperbolic cosine 2x is equal to k sine hyperbolic sine x. Has 2 distinct real roots. Right? So in here, of course, well, we just proved this thing here, then of course, we have to use it. So let's use that. Plus 1 is equal to k sinh x. Can I just call it sinh? It's easier to call it sinh. And of course, you can see that this is actually just a quadratic in sinh. We're just moving the k sinh x to the left-hand side, so we get this guy. Plus 1 is equal to 0. Shine. Okay, sure. Whatever you call it. Whatever. Yeah, of course. Well, since we want to find 2 distinct real roots, of course we have to use the discriminant, right? So let's use the discriminant here. B squared minus 4ac, k squared minus 4 times 2 plus 1, times 1. Since we want 2 distinct real roots, so we have to use greater than 0. Okay, so that means k squared is larger than 8. Taking the square root, well, yeah, kind of taking the square root, you get the absolute value of k greater than 2 root 2. You guys can debate. It's not my issue. Right, and so why does it work here? Well, first of all, when you solve for sinh in this case, you'll get some sinh. Sorry. is equal to some constant. Let's call it c. And we know that there's actually two values, c and c2, right? Yeah, let's call it c1 and c2. And each of them only has one answer, one solution, because this function is strictly increasing, yeah? Uh, as opposed to when you do cosine h, yeah. Then you have two solutions for each c. So that's why you have to be careful in this. But everything is safe here because sinh is strictly increasing. And so there are only two solutions. Okay? So yeah, this is the answer. Right. Anything confusing? Anything confusing? No, yeah, I hope not. Okay, thank you. Right, next question is a differential equation. The variables t and x are related by the differential equation, and we have to find the general solution for x in terms of t. So of course we have to split into two cases first, homogeneous and non-homogeneous. So homogeneous, just so that you remember, it's when it's equal to 0, and non-homogeneous is when you consider the function here. Okay, so for homogeneous, I'm just going to write homo, because it's funny. Yeah, so so of course we have to find, we let x be e power n t, right? X is equal to e power n t. And then we solve for n. We plug it into differential equation, we should get n squared plus n plus 1 is equal to 0. And when you solve it, you should get minus half, I think, minus half, plus minus root 3 over 2i. Let me see one more time. Let me just check one more time. Yeah, okay, yeah. Right. So we have the real part and imaginary part. That means we have to use the solution where there's the e and the cosine and sine, right? So we have x is equal to e to the power of the real part times t, the power, yeah, real part times t, all multiplied by the first constant, let's call it a, cosine of the imaginary part. It doesn't matter if it's plus minus, just take the numerical value here, root 3 by 2, and don't forget to put the t here. And the same thing for the sine. Okay, so this one is homogeneous. Now what about non-homo? Should I remove the second n? No. Okay, so when it's non-homogeneous, that means we have to consider this function here. Well, it's a quadratic, so that means we have to let x be some quadratic with some unknown coefficients. So that means we let x be at squared plus bt plus c. Put some here first. No, okay, then we just have to put this x into the differential equation. What if I didn't use cos, sine, and use e power? That's fine, I guess, but it's better to use this. Better to use this. Looks more, because we don't really do imaginary numbers in this kind of questions in your A level at least. Yeah, so it's better to write it like this. And even in the book, they suggest you to write it like this, in this form. Okay, so let's put it in. The second derivative of this x is just 2a. So 2a plus the first derivative. So that's 2at plus b plus at squared. And then basically just everything here. Let's go t squared plus 1. Okay. So let's do it as fast as we can. First, we see that the t squared only has a coefficient of 1, and this is the only t squared term, so that means a is 1. Now notice that they do not have t term here. There's no t. It's just 0 plus 0t. So therefore, 2a plus b has to be 0. So b is just minus 2 because a is 1. Yeah. And finally, what is c? We just have to take all the constant term, 2a plus b plus c. Well, we know that 2a plus b has to be 0. We don't care. So c has to be equal to 1. Yeah. Okay, so that means our x is t squared minus 2t plus 1. And this is just t minus 1 squared, actually. Now that we're done, just add both cases. Homogeneous and non-homogeneous, just add them up together. That's your answer. Let me write it down again. So tiring to write down. Okay, that's it. Speech to text. It will disturb the whole exam hall. The whole exam hall will be disturbed because you have to talk, right? Right, any questions here? Should be very standard, I think. I hope it's standard. This kind of question shouldn't be so bad. Right, so we didn't even use the second half of the page. Right, deduce an approximate value for the second derivative of x for the large positive values of t. Let me just copy this first. Okay. Right, so let's consider when x goes large first, not the second derivative. Well, when x goes large, then this whole thing has to approach to 0, right? What's the reason? Because this is a bounded value, while this one is approaching 0. So this is the one that brings this value, the whole value, to 0. And that's why this whole thing just goes to 0. So the dominating term when when the t goes large, when the I'm so used to saying x, when t goes large, then the dominating term is this guy. So when t is large, so x is approximately this guy here. Okay, but then we're trying to find the second derivative. So just take the second derivative of this guy. So second derivative of x. So that's just 2. Okay. Yeah. Okay. Oh, I still have some writing here. Oops. All right. So now we have this Riemann sum type of thing. The diagram shows the curve 2 to the power of x for this interval 0 to 1, together with a set of n rectangles, each of with 1 over n. But considering the sum of the areas of these rectangles show that the integral from 0 to 1 is less than un. So un, un is, you can see that it's the upper rectangles here. And they show that un is this. Yeah, so far isn't so bad. Right, so of course that means we just have to consider all these rectangles, right? So obviously from the diagram you see that the rectangles are larger than the graph itself. If I continue, it'll look like that. And it'll be larger than the graph. So surely the integral of this guy must be less than this rectangle. Well, what's the area of this rectangle? Well, it's the height of the graph at 1 over n, times the width, which is just 1 over n. So that means it's 1 over n times 2 power 1 over n. And then you do the same thing. The width is 1 over n. While the height is at when the function is at 2 power n. 2 over n, sorry, 2 over n. So you have plus 1 over n, 2 over n, and so on, up to 1 here. So 1 over n to power of, well, that's n over n technically, right? Which is just 1. Okay. So we can change this into summation form. We can actually just factor out the 1 over n. Doesn't matter. We start from, well, where do we start from? We start from 1, 2, up to n. So that means we start from 1 up to n to the power of k over n, like this. Okay, so this is actually just a geometric sum. If I just pull this and k out, it's just a geometric sum with common ratio of 2 power 1 over n. So what's the formula again? It will be 2 power 1 over n times 2, yeah, 2 power n over n minus 1. Oh wait, no, not minus 1. Yeah, sorry, minus 1. It is minus 1. 2 power 1 over n minus 1, like this. Okay, so this is actually just 2. 2 minus 1 is just 1. And so you get your answer. Okay? Okay, is it clear? Clear? Okay, thank you. Okay, okay. Now we do a similar method to find the lower bound now. If you're not given a sketch, how would you know when to add 1 to the integral? What do you mean by add 1? Take your time to type. It's okay. I'm just not sure what you mean by add 1. I mean, usually if you're not given the sketch then of the area, I saw there were times when finding the upper bound estimation of the area, I saw there were times 1 was added. Times 1 was added. Are you talking about this one? Oh, there were times when 1 was added. When 1 was added? Really? I, for, oh, locker, oh, okay, okay. 'Cause I don't remember doing, I never really memorized those. I just sketch the graph and just find it. If there's no sketch, then you just, I'd say you just sketch it on your own. That should be fine. Okay. Yeah, most of the time, at least in my experience, you'll almost always be given a sketch. Always, right? I haven't seen any example where we don't have a sketch. And also, all of the functions that will be given to you is either strictly increasing or strictly decreasing. You'll never get this you'll never get that. So don't worry too much. Okay. Okay, you're welcome. Right, so let's go for the next part. We have lots of people. How do we have lots of people for a further math session? Using a similar method, we find the lower bound now. Well, just ln. Well, if you want to find the lower bound, instead of looking at the upper rectangles, then we just have to find the lower rectangles, right? So we'll see, look at this guy. This one, this one, this one, this one, and this one, and so on, up to this one. Undercover. Okay. Right, so now we just have to evaluate this. So the same thing. For this case, the width is always 1 over n, so it doesn't change. Width is always 1 over n. But the height is a bit different. Okay? So the height in this case is when the x is at 0, right? So this is 2 power 0 here. That's the height. Well, But in this case, the height is 1 over n now. So 1 over n. And then you just keep following and keep going, up to the last one. Well, the last one now, we're not following when x is 1 because that will give the upper rectangle. Yeah, but now, so now we end at n minus 1. So that's this size 2 power n minus 1 over n. Okay, now that we have this, let's add them up. So we have ln is equal to 1 over n. Starting from n0 up to big N of the same thing. So same thing, this is just a geometric sum. And so we have 2 power, wait, sorry, it's n minus 1, sorry. Okay. Yeah, okay, so that means we have this. Right? Can we just write the upper bound minus the last rectangle, or do we need to show this working to be? I don't think so. You just have to write this. Just write it like that and it's all okay. Even in the marking scheme, it just tells you that, yeah. In the marking scheme, it just says this is greater than this, and then you just have to solve whatever that is. Okay, so so just simplify. This is just 2. So you have 2 minus 1, that's 1. 1 over, and blah, blah, blah. Okay, and that's your answer. Right, not so bad. Okay, so next one. Find the least value of capital N such that the upper sum minus the lower sum is less than 10 to the power minus 4. Well, so let's find it out. Let's consider the un minus ln first. So what's un? Un is this guy right here. Okay, so you guys remember? 2 power n, 1 over n times 2 power 1 over n minus n, minus 1, minus ln. Well, ln, the only difference is that the numerator is different. It's 1, while un has this guy. So just write it down. Okay, and if you notice, these two guys cancel here. You're only left with 1 over n. Right, can you see? Squeeze theorem. Well, there's no squeeze theorem. We don't need squeeze theorem. Okay, so we have 1 over n. So what should n be so that this thing is less than 10 to the power of minus 4? The reciprocal of that, yeah, sure. But you want it to be a strictly, it's a strict inequality right here. So we have something larger, like something larger. Yeah, okay, so that means we just have to pick let n be 10 to the power of 4 plus 1, yeah? So 1 over n is 1 over 10 to the power of 4 plus 1. This is surely less than 1 over 10 to the power of 4. For sure, yeah? And so we have our result. Almost surely. Okay. Okay, any questions here? Any questions? Anything confusing? Just be careful on the rectangles, okay? Be careful on like which one you have to use. Like which height are you taking care of, and that's it. Okay. Right, so next one. The variables x and y are such that y is 0 when x is 0. And this equation is satisfied. Show that the dy dx is negative 3/4 when x is 0. Well, of course, when they ask you for dy dx, then you have to differentiate. Should be your first instinct. Right, so let's differentiate the equation. Implicit differentiation, actually. So differentiating this guy, differentiating x plus 1, that gives you 1, just gives you y. Plus, let me see how to differentiate y now. X plus 1 with the derivative. And now we differentiate the second term. Chain rule, so you have 3 times the inside squared multiplied by the derivative of the inside of the function. So that's 1 plus dy dx. Differentiation of 1 is just 0. So it's 0. Okay. Maybe it's a different time zone. Come on, man. Actually, I don't know what Dax time zone is. Right. So now we're looking for the value of dy dx given when x is 0. But when x is 0, that means y is also 0. So let's just plug everything in. So y is 0. This just goes to 0. Doesn't matter. When x is 0, then this whole thing just becomes 1. Actually, I'm just going to write it instantly. So dy dx right here. Plus x is 0, y is 0. So it just leaves you 1. You have 3 plus 1. Yeah, 3 times 1 plus dy dx. Like this. And you can just make dy dx the subject. You guys should know that. And you have your answer. Okay? Right. So that's done. Part A. Now we go to part B. 7 marks, by the way. It's very intimidating. Find the Maclaurin series for y up to including the term in x squared. I think this is the hardest one in this paper. The hardest question. I don't know. Let me check. I don't think it's the hardest question. Yeah, 7 for Maclaurin. But this is the Maclaurin series given an implicit equation. Yeah. So just to recall, Maclaurin series is basically Taylor series evaluated at 0, right? So fx like this, right? But this time we're dealing with y. So don't use fx, use y. This is y. This is dn y dxn evaluated at x is equal to 0. Like that. Well, since you want the term, you also want to include the term x squared. So for sure, you also need the second derivative. So you have to find d squared y dx squared. And that's the problem. You have to find what it is at x is equal to 0. Oops, sorry. Okay. That means we have to differentiate this guy. I hope I don't make any mistakes. Okay. Right, so let's differentiate this guy again. Differentiating y gives you dy dx. And then we have a product rule. Differentiating x plus 1 gives you 1. So just dy dx again. Now you differentiate dy dx. So you get the second derivative. Oops. And now we have to use the product rule now. Here. I'm just going to pull out the 3. Differentiating this guy will give you 2 times the inside. And then you don't forget to multiply by the inside, the derivative of the inside. So 1 plus dy dx. But there's also another dy dx here. So put a square. And then differentiate this guy. So you have x plus y plus 1 square. Put it up here maybe. Differentiating this guy, well, the constant dies, and you get second derivative here. The second derivative equal to 0. It's very tedious. Yeah, and maybe that's why they give the 7 marks. It's just very, very tedious. Okay. Now that you've already differentiated, you just have to plug in the values. When x is 0, y is 0, and don't forget dy dx is negative 3/4. So let's put everything in, negative 3/4. This is also negative 3/4, so I'm just going to multiply by 2. This is a 2 here. Plus d squared y dx squared. Plus now, just plug in everything. And I hope I'm not making any mistakes. But if you see me making a mistake, please tell me, okay? I hope I'm not making mistakes. This becomes 1 because x is 0, y is 0. And then we have 1 plus negative 3/4. So that's just 1/4. Yeah, so 1/4 square plus, this is also 1, and this is what we want to find. So d square y dx square. Okay. I hope I'm not making any mistakes here. Okay, so now let's solve it. My God. So we have, let's just simplify bit by bit. I'm lazy to write this whole thing. I'm just going to write d square because it's easier. Times 3d square equals 0. And then when you find d square here, you should get 9 by 3 over 2. 32, sorry. Okay, so now, well, since you get, skip steps, you can do the steps on your own. You're the one doing the exam anyway, not me, haha. Right, so that you have the second, now that you have the value of the second derivative, now you can find the Maclaurin. And we'll use the next page for it. So the Maclaurin is y is equal to, so that means it's no derivative evaluated at 0, so it's just 0. Right here. Plus, now you have the x term. So the x term is the first derivative divided by 1 factorial, which is just 1. So you just have to take care of the first derivative. What's the first derivative? Negative 3/4. So you have negative 3/4 here. And lastly, now this the x squared. So this is the second derivative divided by 2 factorial. So the second derivative was 9 over 32. Then don't forget to divide by 2. So you have 9 over 64. 9 over 64. And that's your answer. And you can just remove the 0. Yeah, that's your answer. Why 0 is, because here, sorry, this one here. This one. Yeah, it's okay. Just don't forget in the exam. Chapal. I think there's still the Chapal. Oh yeah, there you go. The Chapal emoji. Okay, any questions for this? Any questions? Anything confusing? Should be obvious. Okay. Okay, Alex. Okay. Right, so should be okay, yeah. Okay, now this one's 10 marks. Sorry. Use the substitution y is equal to vx to find the solution of this differential equation. And it's given that y is 0 when x is 1. Give your answer in the form of y is equal to some function of x. It's so nice that you guys are given the substitution. It is very, very nice. It makes things very easy. So, but let's appreciate that. Right, so that means we have to use the substitution. We start from, well, of course, the substitution. And of course, we want to differentiate it. So we can replace all the dy dx in terms of v and x. So differentiating will give you dy dx is equal to, product rule, differentiating v, so you get dv dx, differentiating x gives you 1, so you just get v here. Right, so now that we know the derivative, let's play with the differential equation itself. So x dy dx to y. Right, so for this substitution, we want to change all the y's, every single y as possible, in terms of v. Jealous. Yeah, I'm very jealous. You're so nice. Right, but if you notice that our substitution is basically when you make v the subject, that is v is equal to 1 y over x. So let's try to make everything in this equation in terms of y over x. So of course, we want to try to divide by x. We have dy dx is equal to y over x plus 1 over x. Right? Of course, we also want the inside here to be in terms of v. So let's pull out an x squared. So you have an x here. And it's so nice because you just assume that x is greater than 0 here. Actually, it's not stated, but who cares? It's A-level math. Okay, so you see that now everything is in terms of y over x. Let me see if I'm making mistakes. So now we can apply substitution. 9. I have always written 9 like that. Are you judging me? Right, so now we make the substitution. We change dy dx into this guy and change all the y by x's into v. Right, so we have x dv dx plus v is equal to, well, this becomes v now, plus square root of 9 plus v squared. This is the v here. Okay, so, oops, sorry. I'll delete this. Right, and as you can see that these two v's will cancel. It's easier to see this guy, okay? Okay, so now that we have this, let's solve it. It's actually just a separable differential equation. Back in your, normal A2 math, very last chapter, separable differential equations, just solve it. So we can, quote unquote, multiply dx on both sides and move this downwards. So we have this guy here. And then integrate both sides. Okay. So of course the right hand side is very easy. It's just ln of x plus c. But the left hand side, let's do some substitution again. So in this case, we'll let v be, and how to find out what v is. Remember that you have hyperbolic sines and cosines, and the identity is as given here. Cos square x minus sinh square x is equal to 1. Yeah, that. You're very excited, I know. Right? I'm just telling you how to find it. Well, since you want a positive number plus a square, then let's move the sin square to your side. Like that. So this is the identity you want to use. This is the key identity. So that means v has to be something in terms of sinh. Sinh of, let's say, u. But then you have just 9 plus sinh square. You can't use the identity unless you have this as 1. So don't forget to put the 3 here. Because when you square it, you get the 9. You can factor the 9 out. Okay, so that now you have this guy. So 9 plus 9 sinh square. Don't forget to find dv. So that's 3 cos u du. Okay. And if you notice, this is actually this whole thing with the square root. It's just 3 cos u. And that's where it all cancel. So just integral of du. It's just u. So now we have u is equal to then, wait, no, sorry. But we know what u is. U is just when you solve for u here. So v over 3 and then sinh inverse. So sinh inverse of v over, v over 3. That means we have this guy, the sinh inverse has to be equal to ln of x. Let's see. Standard integral, I guess. I don't know. Can you use tangent? Yeah, you can use tangent, but it's more of a hassle here. Oh wait, oh it is? Oh, it's in the formula sheet? Oh really? Oh, I didn't know. Oh, okay. I didn't know because I never used the formula sheet to to solve this. I really didn't use it at all. I never used the formula sheet. Yeah. No, I seriously don't. That's why I didn't know. I'm so sorry. I didn't know. I seriously don't know. Okay, well, if you have it in the formula sheet, then it's very, it's good. That's nice. Yeah, good. That means you don't have to go through all these junk. But I had to because I didn't know. Yeah, I look like that emoji actually. You never use MF19? How did you survive? I only use MF19 in the past paper. And then the more past paper I did, the more I don't really use it. I just don't care about it anymore. Oh yeah, except for the statistical tables. Of course, I have to use the... I can't memorize that. I'm not that crazy. Right. Okay. Back to the topic again. So now you have this equation here. So you're going to find the C now. So what's the C? Well, when we're given that when x is 1, y is 0. But when x is 1, then v is also 0, right? Because this is just 0 over 1. So it's just 0. This is the v. So that means when x is 0, then v is 0. Okay, so sinh inverse of 0 just gives you 0. And ln of 1 is also 0. So c is 0. And we can just completely ignore the c. This is just 0. So sinh, I'll make a border here. V by 3, ln x. And now we can solve it. Let's take the sinh of both sides to cancel the sinh inverse on the left. We have v by 3 is equal to sinh ln x. And don't forget that by definition, sinh is just the e power blah blah blah, remember that? This is just e power ln x minus e to the power of negative ln x all over 2. But e to the power of ln x is just x. I can just replace it. So x minus, well, this thing is just ln of 1 by x, right? And now you can cancel the ln. So you have 1 by x all over 2. Right, let's go to the next page. So v by, what the hell? V by 3 is equal to x minus 1 over x all over 2. But remember that v is just y over x. So this becomes y over 3x. And the right-hand side stays the same. Multiply by 3x both sides and you get your answer. Y is equal to 3 by 2, x squared minus 1. And that's it. Okay, any questions? Other than this method, this funny method that you actually don't need to do. Oh, I actually really don't know that you guys have it in your formula sheet. I haven't opened the formula sheet in ages. For real, I actually haven't. But yeah, any questions? Any questions? Okay. So you guys didn't know that that's actually how you do it? No? Oh, what? I think it is in the book, yeah. I remember it's in the book. Oh, in class. We knew, but you just ignored it. Oh, okay. All right, fair enough. Ah, okay. Okay then. All right. Next question. But I hope I hope it's clear. Just tell me if something's not clear, okay? Next question then. Number 7, we use de Moivre's theorem to show that this identity is true. God help me. I don't feel like doing this one. Okay, but it's okay. I'll probably just skip some steps. Right, of course, so cosecant is just 1 over sine. So that means we have to do we have to use the De Moivre's theorem on sine, take the imaginary part. So then that means we have cosine theta plus I sine 7 theta. Wait, no, not 7. What the hell? Theta power 7. And well, of course, this becomes cosine 7 theta plus I sine 7 theta. And you want to take the imaginary part, right? You take the imaginary part, so this becomes sine 7 theta right here. I'm moving it a bit to the left so I have more space. Oh, thanks for the... Okay, yeah, thank you. Thank you for that, Alex. Right, so let's expand. So first of all, since we only want to take the imaginary part, that means it only occurs when the power of sine is odd, correct? If it's even, then it will give something real. And we don't care about real things because we only want the imaginary part. Okay? So we just have to care when I sine power odd, basically. So let's do that. Let's just filter it. So 7 choose 1. I sine theta cosine power 6 theta plus 7 choose 3 now. I sine theta power 3 cosine power 4 theta. Even in this, I don't have space. Whatever. Just put it here. Put a bit more to the left. 7 choose 5. No. I sine theta power 5 cosine square. And finally, 7 choose 7. Like that. Plus all the other junk terms that we don't care. Actually, we don't actually have to write this because we already said take the imaginary part later. Right. And if you simplify this, you should be getting, let's see. Right. Oh, sorry. I should put the im again. Okay. Put the imaginary part. So I don't have to care about the i's anymore now. Okay, so that means we have 7 sine cosine power 6 plus 7 choose 3 is, well, let me see Alex's. 35. Wait, 0, 1, 2, 3, so 35. 35. Well, it's actually minus because you have I cube, so that's minus I. So you have minus now. Sine cube cosine power 4. And then again, 7 choose 5 is, looking at Alex's, is 0, 1, 2, 3, 4, 5. Wait, 21 again. It was 0, 1, 2, 3, 4, 5. Yeah, 21. 21. Sine power 5 cosine square plus, no, it's negative because I power 7 gives you negative I. So negative sine power 7. Okay, just like that. But here's the thing. Well, we don't want any cosine terms, so we have to make everything to sine. So let's do that. Remember, so you just have to use the identity. Cosine square is 1 minus sine square. And we just have to change everything here. Very tedious, I know. How many marks is this? 6. It's not worth 6 marks. I'd say if you give me 15 marks, then I'll do it. Okay. I don't care how you simplify this. I'm not doing it. I'm just using the marking scheme. Okay, and this is what you should get when you simplify. Oh, okay. Wait, let me rewrite this one. Okay. All right, so this is sine 7 theta. Okay, now that you have this, all you have to do is take the reciprocal. because you want to find cosecant, right? So cosecant of 7 theta is 1 all over all of that. I'm sorry it takes very long for me to write. I write very slowly. And then from here, well, you want everything in terms of cosecant, right? And the highest power in this case, yeah, the highest power here in this case is 7 for the sine. And you don't want that. So you have to multiply numerator and denominator by cosecant power 7 to cancel the sine 7 here. And that's where you get your answer. Minus 64 will, well, yeah, it will be just minus 64 plus 112 square, yeah, square minus 56 cosecant power 4 theta. I have a longer one, 7 cosecant theta power 6. Yeah, and it should be the, yeah, it's correct. Yeah, okay. And that's how you do it. Although I'm not doing this step because it's too much. You guys can do it, right? Yeah, I believe in you guys. You can do it. Okay, let's go to the next question now. And the next question is, now we try to solve for the roots of this equation. Well, the word hence means that we have to use the previous part to solve this. So first of all, what's familiar about this question? Let's take a look at the coefficients here, 14, 112, 224, 128. And if you look at down back here, notice that they're actually just twice the coefficients. 756, 112, 64. And here you have, yeah, and here you have 14, right? So that's the first familiar thing. And one more thing is that the coefficient is not only twice, but it's also negative. So that means it tells us there's a minus, some kind of times 2 or minus 2, whatever. But the point is that we try to make it as much as possible. We're going to make it into this form. Okay? So how do you do that? Well, first of all, you have a, if you let's say if we imagine that x is cosecant theta, then we want this, we're going to have x power 7 all over this blah, blah, blah guy. So let's transfer everything here to the other side. X power 7 is 14, x power 6 minus 1, 2, x power 4 plus 224 x squared minus 128. Right. And we can actually just factor this 2 times what we have. 54. Now you see that everything looks familiar. Let's divide both sides by this polynomial here. So you have x power 7 all over this guy. Minus 54 is equal to 2. So then if you let x become cosecant theta, now you have cosecant theta. Cosecant 7 theta is equal to 2, not minus 2. And so that means you just have to solve this. So let me just put it down here. Going here is you let x become cosecant theta. That means all the roots of x has to be in the form of cosecant blah, blah, blah. Okay. Now we just solve this. Cosecant is just 1 over sine. So flip both sides. You get sine theta. Sine 7 theta. 1/2. Sorry. Okay, so now we solve this. So remember that by ASTC or whatever method you want to use, we get that sine theta, taking the sine inverse, gives you, we're using radians, right? Yeah, we're using radians. So it's pi over 6 for the first case. But remember, there's also another angle. You get it from pi minus the alpha. And in this case, the alpha is pi over 6. So there's actually 270 7 theta is pi minus pi by 6. That's 5 pi over 6 right here. And don't forget, since sine is periodic by 2 pi, so we have to add the multiples of 2 pi. So I should write this as, just to make it easier. Okay. Okay. So how, now, actually, this is, many people have already asked this question in the discussion, I remember, in the chat. What range of theta should I find? I think that's the most confusing part. Until where should I stop? How many? What's the range of theta I should find? Since we're doing sine, the range is just theta from minus pi by 2. Oh, wait, from minus pi? Yeah, minus pi by 2 to pi by 2. This is if you're dealing with sine. I'll write it here, actually. If it's sine, you deal with that. If it's cosine, instead of from minus pi by 2 to pi by 2, you go from 0 to pi. So 0, pi. Like that. And the MF19, really? I have no idea. Anything with the MF19, I didn't remember. But okay, yeah. In case you didn't know, then that's it. Can I just sub all the possible roots and eliminate duplicate roots by solely making a statement that, let's see. Yeah, sure. Yeah, you can do that. Yeah. Yes, you can. You can. And the marking scheme even allows you to say like to have other values as long as it's equal. So it doesn't have to be like in this. It doesn't have to be in this range. But if you want it to be easy, then you don't have to go so far away from the center. Then just stay in this range. I just do multiple still, I'll get the record number. Yeah, you can also do that. Yes, you can also do that. Amount of roots of the highest power. That's also okay. Yeah. Any method is fine. That's what I also did back then. I just find all the possible roots and then kill the duplicates until I get 5 answers, right? 5 solutions. Oh, no, sorry. 7. In this case, 7. Fundamental theorem of algebra. So 7. That's what I did back then too. But for those who are lazy to do that, then this is the range of values for you to find. Okay. So now we have 7 theta as this guy. That's this whole thing. Let's divide by 7. F theta. So pi by 42 plus 2k pi over 7. 5 pi over 42 plus 2k pi over 7. Okay, so now let's check one by one. So what are the values of theta here? Let's use this one first. Of course, pi by 42 is an answer, is a solution. And what else? You just have to keep adding until, as long as you don't, cross 21 over 42 pi, right? Because this is just the same thing as 21 over 42 pi negative 21 over 42 pi. Just don't go cross that and you'll be fine. Okay. So 2k pi by 7. You add two. You add this guy here. 1k is 1 instead. So I can't remember my answers. So I'm doing it in my calculator now. That's 13 pi over 42. And then when you let k become 4 now, oops. So this time when you let k become 4, you get 25 over 42 pi, which you do not want because it's all already over the pi over 2 line. Yeah, also you can also write it like that. Whatever, it's fine. Wait, can you? You have. I don't think you've, Alex. I don't think you've, make this to 42. So this should be 14. Okay, so that means we can't go further to the right. So let's go to the left now. Instead, if we have minus two instead, so we let this to be minus 1. Yeah. So yeah, yeah. Of course, you can subtract it. So that now you have negative 11 pi over 42. So this k actually just means any integer. 0, 1, minus 1, 2, minus 2, 3, minus 3, and so on. So this is when k is, oh, sorry, k is 1. This is when k is minus 1. 1 over 42 minus 4 over 7. And if you go to like k minus 2, then you'll get negative 23 over 42 pi, and which you do not want because it already crosses the negative pi over 2. Okay, so these are the three solutions from this guy, from this one. Now let's move on to the second version. So surely 5 pi by 42 is an answer. This is a solution. Now when k is equal to 1, let's find out. So take some time. Okay, you get 17 over 42 pi. Oh, well, when k is 2. Let's see when k is 2. Oh, you get 29 over 42. You already crossed it, so reject. So let's go backwards now. When k is minus 1, you get negative 1 by 6 pi. So that's fine. Negative 1 by 6 pi is not all over negative pi by 2 yet. Let's subtract one more. Negative 19 over 42. And this is okay, because it's not over the 21 over 42 pi. There. Okay, so these are all your answers, or all your theta. And then now x is what? You just have to change this into q. Okay. Oh wait, no, sorry, just theta. And your x is just the cosecant of all of this in here. Okay, 5 marks. Okay, any questions? So that's the answer. Just put all the thetas there inside the cosecant, and that's the answer to your, to finding the roots. Okay, any questions, guys? Anything confusing? Okay. All right, I think this is the last question. Yeah, last question. Okay. Find the value of a for which the system of equations does not have a unique solution. It does not have a unique solution. So first of all, and you should decrease the marks for differential equations. Increase them for all complex. Yeah, I agree. I agree. Because differential equations are easier. Okay, so for this one, notice that this system of equations will always have a solution, no matter what your A is, because it's all 0, 0, 0 here. It's a homogeneous. So if you just let all x, y, z to be 0, then that's a solution already. But so that means if you don't want it to have a unique solution, then yeah, your determinant has to be 0. Because if your determinant is not 0, then it has a unique solution, yeah. And that unique solution is just x, y, z is all 0. Right? Yeah, should be. Yeah. Should give 5 additions. Okay. I wish. You wish. Okay, so that means we just have to take the matrix and then we take the determinant equated to 0. Let's do that. 3a 0 5 minus 1 0 1 3 2. Okay, so this is what you want to find the value here. Are there any way aside of the determinant to prove unique or no solution? Just row echelon. Row reduction, yeah. Row reduction. Row echelon form. And then you just find. Sub the first enter columns and change sign. Actually, first enter column and change sign. Why do I need to do that? Usually when you guys take the determinant, you always use this one, right? It is matrices. Yeah, it is matrices. Calculus on leading also. It doesn't matter. Usually when you guys take the determinant, you always use this row, right? Oh, at least in the book, it mostly uses this one. But you can also pick other rows or even columns. I can also pick this one right here. Yeah, just solve the x and z's. I can do going down or to the right because transpose of determinant doesn't change the value. Okay. And if you do this, well, you have a 0 and 0. We don't even have to care about this cofactor or this cofactor. We just have to care about this one. So 2 times determinant of 3a5 minus 1. What's this? 2 times minus 3 minus 5a. We want this to be 0. Well, right? If it doesn't have a unique solution, then the determinant has to be 0. Equate to 0, that means a is 3 over negative 5. Or just, yeah, put a negative outside. Doesn't matter. Okay, and that's your answer. How do you use row reduction? My God. You basically just try to eliminate all the x's. But row reduction, the point of row reduction is basically, let me draw the augmented matrix first. 1, a minus 1, 3, 0, 0, 2, 0, 0, 0. Or would you willingly let him be? He's just curious. Well, the point of row reduction is you're going to make the lower triangle to be 0. This is 0, 0, 0 here. That would be easier if you just switch the bottom with the top one here. Right? Well, actually it doesn't matter. Never mind. It doesn't really matter. But the point is that you do row reduction and you're going to make all these terms 0. But as you do that, you'll also change these numbers here, and you find for what a will things not work. You have to find the a so that all the things will not work basically. Okay. Okay, no problem. Right. Now let's do the next part. The matrix A is given by this, so it's very nice. It's when a is 0 actually. Yeah, when this a is 0. Find matrix P and the diagonal matrix D such that a square is PDP inverse. So it's just diagonalization, right? Okay, so then diagonalization, that means we have to find the eigenvectors. The P is the eigenvector matrix, D is diagonal, the eigenvalues, and the P inverse, good luck. Okay? Yeah, well, we just have to find the P. So we just have to find the eigenvectors. But before we can find the eigenvectors, we have to find the eigenvalues. So let's find the eigenvalues. Finding the eigenvalues requires you to find the determinant of a minus lambda I, and this is equal to 0. Yeah, for the higher math you go, the more fun it gets, and you get happiness. That's why you should major in math. Never major in math. Right, so let me write this down again. So a minus lambda I, so you just have to minus the diagonal by lambda, like that. So 3 minus lambda, 0, 0, 5 minus 1 minus lambda, and 1, 3, 2 minus lambda is equal to 0. So the nice thing is that, yes, since we have, so this is like a triangle matrix, the upper triangle is 0. So that means we can just multiply the diagonal. So we get 3 minus lambda times minus 1 minus lambda plus 2 minus lambda is equal to 0. And from here, it's obvious what the eigenvalues are. So lambda is equal to 3, minus 1, and 2. So these are your eigenvalues. You just have to show, the marking scheme doesn't even tell you that. The marking scheme just straight ahead. The first thing that came out in the marking scheme was eigenvalues are these. So even if you don't write this at all, technically they should give you a mark. technically. But of course you can't do that unless, I don't know, magical brain. Yeah, so it's CAIE. Just write, if you think that they're not going to give you a mark, better write it down. Okay, so with these lambdas, let's find the eigenvectors. Let's find when lambda is 3. The eigenvalue is 3. So of course, the top row will be 0. 3 minus 3 is just 0, everything. But then this will become minus 4. This becomes minus 1. So you have these two vectors. So to find the eigenvector, just take the cross product of these two vectors here. So let's do that. I, j, k, 5, minus 4, 0, 1, 3, minus 1. Yeah, like that. Are there any ways other than using AE lambda, it's lambda, not lambda, E to check whether our eigenvalue and eigenvectors are correct? Is there? I mean, I don't. The easiest way is just to multiply to the matrix itself and see that it's parallel with the correct eigenvalue. But that I don't think there's any way else. I don't think so. But if there is, then that's good. But I don't think so. Yeah, sorry about that. Okay, so let's find this vector. So same thing, you can do your cross product normally, determinant, and you should get this vector here. Yeah, you can use your calculator to find. Your calculators can do matrices, right? I'm pretty sure it can. It's the Casio. Right? Yeah, the Casio calculators. Okay, so that's for lambda is 3. Let's do when it's minus 1. When it's minus 1, we have 4. 0, 0, yeah. This is just 4. And then we have, when it's minus 1, so this is just 0 here. So 5, 0, 0. So notice that this becomes parallel to this. We don't want to take the cross product of these two things or else it'll become 0. So that means we just have to take the cross product of this vector with this vector. And this is just 2 minus minus 1, so it's 3. Okay, so now let's do cross product again. 4, 0, 0, 1, 3, 3. And if you do your cross product, you'll get this as your answer. But this is parallel to 0, minus 1, and 1. FX991. Yeah, mine is FX991EX. The black and white color Casio. I got this for free. I got my, the 991EXs for free. Okay, so for the last one, lambda is 2. So lambda is 2. I, j, k again. When lambda is 2, we have 3 minus 2, so that's 1. And then minus 1 minus 3, so that's minus 4, right? Wait, 2? Sorry, minus 1 minus 2, sorry, so it's minus 3. And then 1, 3, 2 minus 3, so it's negative 1. Am I doing it wrong? Oh yeah, sorry, it's 2. I keep forgetting it's 2. So this becomes 0, minus 1 minus 2, that's minus 3. Yeah, okay. Right? And let's see if there's... Okay. Am I in the IMO team? Never. I've never been in the IMO. Yeah, this cross product is so efficient. Very, very efficient. So I'll just take this vector and this vector, okay? So that means we have 1, 0, 0 right here because, yeah, 3 minus 2. And I'll take this one too. So it's 1, 3, 0. 2 minus 2, 0. Is there a worse method? Yeah, there technically is. You basically just solve the equation normally. This works because you're doing 3 by 3 matrices. If you're doing 4 by 4, then no more. Only works for 3 by 3. Okay, so you have this. Take the cross product. You should get 0, 0, 3. But this is parallel to 0, 0, 1. Okay, so that means your P matrix is your eigenvector matrix. So this one, and this one for I 4, 5, 9, 0 minus 1, 0, 0 minus 1, 0, 0, 1. And what about your D? No, not your D, but your D matrix, I mean. 19. Oh, oh yeah, 19. Thank you. 19. We don't talk about that. So we want to find this diagonal matrix D such that it satisfies this, right? So it is not for A, but it is A square. But A square really just has the square of the eigenvalues, right? So you just have to square the eigenvalues correspondingly. You get 9, you get 1, and you get 4. So you have 9, 1, 4. And that's your answer. That's your D matrix. Okay, any questions? No, what? Say what? I didn't say anything. I said that's your D matrix, yeah, your diagonal matrix. Yeah, well, nothing wrong with it. I don't see anything wrong with it. Right, this is the very last question. Part C. Use the characteristic equation of A to show that this equation is true, where B is an integer to be determined. You have an equation in terms of A, and you're told to use the characteristic equation. That means we have to use the Cayley-Hamilton theorem. Cayley-Hamilton theorem. It's Cayley plus Hamilton. Not the Hamilton from the play, okay? Not the Broadway Hamilton. It's another Hamilton. Right, so what does it state again? Well, let me bring this here. Lewis Hamilton. Okay, so we have this. Let's expand this. So let's expand this. So we expand this when we should be getting lambda cube minus 4 lambda square plus lambda plus 6 is equal to 0. Right, so what does Cayley-Hamilton theorem states? It states that, well, this is your characteristic equation. If you replace the lambda into your matrix, A, it will still satisfy the equation. So if you change it to A instead, so instead of lambda, we have A, the matrix A, minus 4A squared plus A plus 6. Well, because this is matrix, so you have to use I. Don't forget to put the identity matrix here. It states that it is still going to be equal to 0. This is equal to 0. Indeed, like it's an identity. Now, it's now an identity. That if you add all of these up, it will be 0. Basically just replacing all the lambdas into A. All right. So now what's next? Well, first of all, well, you need to find A plus 6i. And you have that. You have A plus 6i. So let's bring all the other junk to the other side. So now we have A plus 6i is 4a squared minus a cubed. And actually, we can factor out the a squared. I think that's a good thing. 4 minus a, or I minus a. So we're actually really close. We just have to square it, right? If you square it, you get a square here, and you get a 4, which we want. So let's do that. Let's square it. So a plus 6i squared is equal to a power 4. 4i minus a squared. But when you square it, doesn't really matter about the minus. You can just switch it around. So let me just switch this around. Square it. A minus 4i. And so this is your b. So b is negative 4. And that's it. That's how you show it. Okay? Any questions? What's the time given for this exam? 2 hours. We did it for 1.5. We're really fast. The recording is being recorded, yeah. Hello guys. Yeah, hi. So how do you check after completing it? Since you have half an hour left in your when you're doing your exam, you can sleep. Or you can redo all the questions from the start. Like let's just Yeah. So of course, if you have half an hour, then um, try to check your answers again, especially if it's the computational heavy one, like like the Moivre's theorem part. Where is it? Yeah, like this. You may make some mistakes in the middle, but then if you make some mistakes, you wouldn't get your answer. But yeah, usually the heavy computational parts like this, usually like this, or the Maclaurin one, you better recheck it. I'm not coughing today because I'm fully cured. Beautiful. Okay. So that's the whole paper. You guys have any of your own questions? You said the paper for you? Okay. Let's do this one. Let's do what Acid sent. But whatever you guys send me, it'll be impromptu for me, so I really don't know how to answer it. Yeah, I have no idea how to answer it, so I'm doing it my first time. No, you never asked me this before, so I have no idea. Valentino. He'll finish both in half an hour. How to do inverse? No, I don't want. I'm not doing 10 by 10. Nah, no thanks. Wrong thing. Oh. Okay, so okay, let's do your question here. Let me see. So let z be cosine theta plus I sin theta. Okay, let me write it down first. Use the binomial expansion 1 plus z power n, where n is a positive integer, to show that all that sum is okay, sure. Right, so we have 1 plus z power n. I'm pretty sure you have to take real and imaginary parts here. Help with explore answer. I'll do it later, yeah. After I'm done with this lesson, with this question, can you send the question again? Because I know the question will be going up and up and up the more people talk. Thank you. So let's do this question first. So we have to, yeah, I'm pretty sure we have to use imaginary and real part here in this question. Because you have all cosines and then all sines. So yeah, I'm pretty sure you have to take real and imaginary part. All right, and the question is how. Okay, so I think Mm, from what I see, from the two sums in the left side, if you add them up, if you multiply by I in the sign, and then you add it up to the first one, you'll get you get the expansion of this guy actually. So you have 1 plus c plus n choose to c square up to n choose n minus 1, the n minus 1 plus c power n, like this. Okay, so now, because we know that z is this guy, so that means we know that this is just cosine theta plus I sine theta plus n choose 2 cosine theta plus I sine theta square. But then when you square it, you just get 2 theta by de Moivre's. So I'll just cosine 2 theta plus I sine 2 theta up to n choose n. Cosine, do I have space, n theta plus I sine n theta, like this. Okay, send them again later, okay? Send them later. And the question's Mr. Agile Metaphor. But I'll do PR case first because he sent first before. Right, so now we have this. And if you notice, if you just take the imaginary part or a real part, then we get the sum. We get the sum if we take the real or imaginary part now. Now the only problem is, how do we deal with this? So 1 plus z power n again now. This time I'm not going to expand it, but I'm going to replace z by the definition. 1 plus cosine theta plus I sine theta n power n. Now here's the thing. They already gave you the answer for when you sum all the cosines. That's one cuff. But then they also tell you that the theta becomes over 2. It just somehow becomes theta by 2. So that's a hint that where you should use somehow the double angle formula, maybe double angle, something that halves the angle. So what can we do here? So I can see that 1 plus cosine theta, I can use the identity 1 plus cosine theta is equal to 2 cosine square theta by 2. And you see that that's how I produce the theta over 2. So we have 2 cosine square theta by 2. Now what about the sine? Well, for the sine, the only identity that I can produce the theta over 2 is by the double angle, right? So sine theta is 2 sine theta over 2 cosine theta over 2. So let's write 2i sine theta over 2 cosine theta over 2 power n. And then from here, and this is the reason why you have cosine power n in the answer there, because you want to factor out the cosine power n and also the 2. So you get 2 power n cosine power n theta over 2 multiplied by cosine theta over 2 plus I sine theta over 2 power n. And then from here, you just use the de Moivre's. Yeah, you just use the de Moivre's, 2 power n cosine power n theta over 2 cosine, I'll use brackets again, and theta over 2 plus I sine n theta over 2. And that's it. Why do you have an I? Because this is further math and you deal with complex numbers, imaginary numbers. I represents the imaginary number. Here's a clear image. Nice hand, bro. Okay, so now that you have this, all you have to do is just to equate real and imaginary parts. That's it. And that's your answer, okay? If you take the real part, then it's equal to the real part, yeah? Just take the real part, real part, real part. And if it's the imaginary part, just take the imaginary part, and imaginary part, imaginary, imaginary. And that's your answer. Okay. Wow. Right, so, okay, it's the one you send me here. So the explorer, right? In groups of pairs, in groups or pairs, experiment with a particular integral that will work for the second order differential equation. particular integral. And with a particular integral, what do you mean? An integral that will work? Maybe you should dt. Not sure what it means by finding. Yeah, I have no idea. other than solving particular integral that will work for the. Well, I don't know. Let's try solving it. I have no idea. D square x dt square plus 4x is equal to 5 cosine 2t. Okay, so as usual, let x be e power nt. So n squared plus 4 is equal to 0. So n is plus minus 2i. No real parts. There's no e. So it's nice. So we have that x. The homogeneous is when x is a cosine 2t plus b sine 2t. That's nice. And now for the particular, the non-homogeneous one, we have a cosine 2t. That means we have to play with trigonometry, right? So x is, well, I don't want to make it the same here. Oh, I see. That's the problem now. So we have a 2t and also 2t. I see. Alternatively, oh, okay, that's a nice alternative. You always like to do that. Not a bad thing to do. Okay, so this is a problem now. And I forgot what you should do. Multiply by t, right? Put a t. Yeah, I think you should put a t as a factor here. So at cosine 2t plus bt sine 2t. Is it like that, Alex? I kind of forgot. It should be like that. When it's e power, yeah, you multiply by t. When you have the same frequency here, all of these are 2t. That means as in the homogeneous solution, there's the same, what do you call it, frequency? Yeah, same frequency in the cosine and sine. So that means for the particular solution, that means you just have to multiply by t, right? Kind of forgot, but yeah, I think that should be like that. Tuned out. But yes or no? Yes or no? Do you know? Do you remember? I don't know if you remember. Simple harmonic motion. I don't. I don't do physics. No idea. Okay, so it should be like this. So let's take the derivative then. Good luck to everyone. I'll remove the t first, so that looks easier. Just factoring out, basically. Imaginary simple harmonic. Simple harmonic as in the general solution. Yeah. Oh, okay, there you go. Thank you. Yeah, there you go. Thanks for that. You just have to multiply by x. Yeah, multiply by t in this case, by the independent variable. Okay, so let's do it. Product rule. A cosine 2t plus b sine 2t. This is when we differentiate t. Now we differentiate the second term. So we have t times minus 2a sine 2t plus 2b cosine 2t. Okay. But that's not enough because we need x. Yeah, x double prime, second derivative. Oh my god, help me. Okay, so let's differentiate. We have minus 2a sine 2t right here, plus 2b sine 2t, plus, now we differentiate this guy here. Yeah, so differentiating t, we'll just make it to 1, and we'll get the same answer as this guy. Copy pasting is my passion. And now you differentiate the inside. So I don't have space, so I'll do it in the bottom. T times differentiating sine to t gives you negative 4a cosine 2t. And this becomes negative now. 2b minus 4b sine 2t. Like this. You wish you could. Okay, so let's simplify a bit more. I think we can simplify. This is just twice of it, so minus 4a cosine 2t. Wait, sorry, not cosine. Sine 2t plus 4b sine 2t plus whatever that's left. Unchanged. They're unchanged. 4b sine 2t here. Okay. Second term should be 2b cos 2t in the second derivative. 2b cos. Oh, right. Thank you. Cosine. Yeah. Okay. Just have to change cosine. Thank you. Thanks for reminding. Right, now that we have this, let's put it back into the differential equation. All right, since they're all in the same, they all have the same inside. They're all 2t. Yeah, the intention to make sure we're paying attention. Yeah, oh yeah, of course. Yeah, of course. Right, so let's put that back in. So I'm too lazy to write sine and cosine, so I'll just use s and c. S plus 4bc plus t minus 4ac minus 4bs. Yeah, s. And then plus 4. T, well, the x, what's the x before? This is the x. So AC plus BS. AC plus BS is equal to 5C. Right here. Amazing. Amazing. Now what? For AC, BS. Oh, this one cancels. This cancels right here. Yeah, can you see? It cancels. Just factor out the negative 4 and you see that cancels. Right, so now we have 4AS plus 4BC is equal to 5C. So now we can see that A is 0 and B has to be 5 by 4. And hence your non-homogeneous solution is all just 5 over 4t sine 2t. Just like that. So, and now that we have homogeneous and non-homogeneous, just add them up together now. So A cosine 2t plus B sine 2t plus 5 by 4t sine 2t. Okay? And I'm not sure what the particular integral. No idea. No idea. I have no idea. The question is up there. What big brain? What big brain is there? I don't think I did anything that's big brain. I hope this helps. Particularly, it's just the y that you add. Sorry. Particular solution. I think they made a typo. Should be particular solution, I think. Particular solution, yeah. Now that makes more sense if it's particular solution because you have to find out. That's where we discuss like, well, what should we do? Should we multiply by t here or what? Yeah. So it turns out, yeah, you have to multiply by t. Okay. So that's your answer apparently. So this is the key part. I'm just gonna put a star. No problem. Next question. Oh my god. If it's I hope you guys understand that it's kind of hard to do it impromptu, you know? You have to explain what you're doing while not knowing what you should do. It's not easy. There's one more question. Somebody sent another question. I don't remember who. Oh, agile metaphor. Yeah, agile metaphor. Okay. Okay, yeah, there you go. Okay, thank you, thank you. Complex question. So let's do it. Does the first math syllabus cover how to find a future wife? No. Okay, so let's do that question now. Right, I hope everybody's also seeing the question. State the sum of the series from 1 plus w squared up to w n minus 1. So this is for part A, 1 plus w squared, where w is not 1. Okay. Well, of course, this is just geometric sum. So it should just be like that. Okay. Right, so this is all. This is just this geometric sum. Okay. Now we go B. So show that 1 plus, okay, show 1 plus I tangent theta k, power k, yeah, is equal to secant power k theta cosine k theta plus I sine k theta. Okay, sure. So, well, in this case, you just have to, well, you have a tangent, right? A tangent, which is sine over cosine. So 1 plus I sine theta over cosine theta. And you see that you have a k theta here. That means we have to use De Moivre's theorem at some point. And how do you use the De Moivre's theorem? That is, if you have, just write the k first, if you have this cosine theta here. But to get this cosine theta, that means you have to factor out the cosine theta outside of this bracket. So that's where you get the secant theta, k theta. So now you have cosine theta plus I sine theta per k. And that's where you apply the De Moivre's theorem. And it's also a good thing that they stated that theta can't be equal to this, because or else goodbye. And goodbye to this guy also. You have a undefined thing. Alright. Right, now let's do part C. Part C, by considering the sum of this guy, apparently. Yeah, the sum of that. Show that, okay. Sorry. Right. So let's start from him then. From 0 up to n minus 1. 1 plus I tangent theta power k. And you want to show that, and you want to find, we want to find this. Oh, you have to go? Bye-bye. So we're going to find, actually it's not find, it's actually show. So I should write show. Want to show. This is what we're going to show. So that means we have to take the, well, from here you can see that we just have to take the imaginary part once we expand it in. Okay, once we take the imaginary part, yeah, later lah. Yeah, this is the imaginary part, that means. Okay, So we know that the imaginary part should give this. So this sum is n minus 1. And let's see. Yeah, secant power k theta times sine k theta, if we take the imaginary part. So this is the imaginary part of this guy. N minus 1. 1 plus I tangent theta power k. But then, this is just a geometric sum again. This is just geometric sum where the r is 1 plus I tangent theta. So don't forget to bring the imaginary part operator here, down here. And then do the thing. 1 plus I tangent theta power n minus 1. 1 plus I tangent theta minus 1. And the 1 and minus 1 will cancel. So I can just delete them. Just like this. Okay? So imaginary part here. All right, so from here we have a 1 plus I tangent theta, and you want to find the imaginary part. So why not try your best to use the Mover's theorem? That means we have to factor out a secant power n. And that's where we get the secant power n here. Am I doing this correctly? 1 plus n minus 1. Yeah, okay. Okay. Should be fine. No need to convert to exponential form. So we have secant power n theta and the cosine theta plus I sine theta power n minus 1 all over I tangent theta, just like this. Okay, now that we have this, we can apply the Mover's. So you have n theta now, and n theta. Secant power n theta cosine n theta plus I sine n theta minus 1 I tangent theta. So which one's the imaginary part here? If we expand this, we see that we can split it to this guy, this one's together, because they're all real, and this is the imaginary part. But then don't forget you have an I at the denominator. So if you only take this one, it'll become real. That means you have to take this one. This is what you want to take. So, but what is it? What is it? Well, this is just 1 over I, right? You can rationalize it, you get minus I. So if I rationalize it, this becomes negative I. So that means when you take the imaginary part, you should be getting 1 minus secant power n, power n theta, cosine n theta, all over tangent theta. Yeah, and that's it. That's where the cotangent theta came from. Okay, any questions here? Is it okay? Is it okay? Anything confusing? Okay. Okay, let's go to your next question. Wow, we have to. Oh, that's a scary looking. All right. Using the substitution, u is equal to 1 minus theta minus 1 square. We have to solve for that integral. So theta minus 1, 1 minus theta minus 1 square, d theta. Right here. And you're already told to use the substitution, so let's just use the substitution already. 1 minus theta minus 1 square. Du will be negative 2 theta minus 1 d theta. Okay, so let's apply the substitution then. That means we have, well, I can cancel this with this, and I'll just have minus 1/2. Minus 1/2 comes from here. And also notice that this is just the u. So you have 1 over u, du. Okay, now that you have this, just integrate normally. you have negative root u plus c. Substitute back the u in, and you have your answer. Okay, this is for A, 3 marks. And then the scary part is the next part. It's 11 marks. Oh my god. You might need the next page for this. Find the solution of the differential equation where theta is between 0 and 2, given that y is 1 when theta is 1. So we have to find the particular solution. Oh my god. Give your answer in the form of y is equal to function of theta. Right, let's do it. Let me write it down first. Oh, this looks very scary. Theta minus 1. Okay, so this is just a first order linear differential equation. That means we have to find the, what do you call it again? Integrating factor, right? Integrating factor. So in this case, the integrating factor will be e to the power of whatever the coefficient of y is. In this case, that's negative 1. So you have negative 1 d theta. Now you have my negative theta here. Sorry. No, sorry. No, sorry. Before you can do that, you have to make the coefficient of dy d theta 1 first. So you don't want this theta here. So we have to divide by theta first. Sorry. dy over d theta is equal to, minus 1 over theta y theta sine inverse theta minus 1. And then now this is the coefficient of y. And this will be our integrating factor. Plus ln theta. So it's just 1 over theta. Yeah, it's just 1 over theta again. Multiply by 1 over theta to both sides of the equation. So you should be getting 1 over theta, dy d theta, minus 1 over theta squared, y is equal to, this one will get cancelled. So you have sine inverse of theta 1, theta minus 1. Now the left-hand side is a product rule, is a result of a product rule. Yeah, it is a product rule of y times, well, whatever your integrating factor is, it's just 1 over theta. So I can just write y over theta here. And now you have to solve for y, so you have to integrate both sides by theta. So we have to remove this differentiation here. So y over theta has to be the integral of sine inverse theta minus 1 d theta, like that. Okay, so up here, up until here, is it okay so far? Can you follow? After this, we have to do the integration. All right, so let's do integration now. Integrating sine inverse requires you to do integration by parts because we don't know what to do with sine inverse, but we know how to differentiate it. So let's do integration by parts. We integrate one and we integrate one and differentiate the sine inverse. So integrating one gives you theta. So theta sine inverse theta minus 1 minus the integral of when after you differentiate the sine inverse. So minus theta. Differentiation of sine inverse is not easy. No, it's just okay. So 1 over square root of 1 minus theta minus 1 square. Yeah. Okay. Oh, okay. So here's the thing. It may be confusing because we don't have a theta minus 1, right? If I put this up here, theta here. We're only given the method on how to do this integral, but not doing this integral. We're missing the minus 1. So how do you have the minus 1? So, we can use the previous part to help with us. Remember when we do integration by parts, we integrate 1, right? Remember that? We only integrate 1. And when you integrate 1, Well, for sure you get a theta, that's for sure. But the constant of integration is up to you. You can even put +1 here. That's fine. Or you can even put -1. So I can change everything, every theta that the one that I integrate into theta -1. So this is -1 and this is not -1. And now we know how to do this because we already did in the previous question. So this becomes theta -1 sine inverse theta -1 minus what we got here. Well, this is a minus, so it becomes a plus now. Plus square root of 1 minus theta -1 square plus c. Okay? That is so dumb but smart at the same time. If it works, it works. Well, yeah, it works. And that's a trick not many people know because they just, oh, integrate. Who cares about the concept of integration? In this case, we want the constant of integration. We have to put a -1 in it. In some cases, you have to put some other constant so things will cancel correctly. In this case, we do -1 because we just did a -1 here. Okay, and it works, right? Technically, it's legal because that is an antiderivative of 1. Theta -1 is an antiderivative of 1. So it's not a problem. Okay, so now let's make a new page here. Y over theta is equal to the biggest fear I have is what if I'm impromptu explaining impromptu and I don't know what to do. Okay, so it's given that, well, we want to find a particular solution, right? So we have to find what C is, but we know what, but we're given that Y is 1 when theta is 1. So given that Y is 1 when theta is 1. Just plug in everything. So 1 is equal to theta -1 is 0, 1 minus 1 is 0. Goodbye to this guy. Theta -1, that's going to be 1 minus 1. So it's 0. So you just have a root 1. So you have 1 plus C. And so your C is just 0. And that's it. Now you just multiply by theta both sides. So Y is equal to theta times theta -1 sine inverse theta -1 plus theta and everything. Just write everything down. And that is your answer. Okay? Not bad if you know the trick. So was that the biggest problem that you had before in this one? Yeah, okay, yeah. Bringing in, yeah, -1. Actually, you're also okay to not do that. Let's say you don't put the -1. Let's say you don't. Let's say you don't. Let's say you did not, and you have no idea about that trick. Let's say you have no idea about that trick at all, and you're gonna solve this. Well, first of all, it's fine. No worries. You want a -1, just like before. You want a -1 up here. So why not add one? Just add one. It's okay. But at the cost of adding it back. So now you know how to solve this, and all you're left to do is to solve this. And this is just 1 over root 1 minus u squared. So it's going to be like sine inverse of theta -1. So it's either you do that trick or you do this. You have to force the -1 in there, but at the cost of adding it back. So it's plus 0, yeah, adding 0. So no problem. Yeah. Yeah, correct. Manipulate your way to use the previous part to get your answer. That's fine. Yeah. Okay. And that's it for all your questions. Any other? Um, whew. Any other? Any other? Ah, God. Okay. Or anything that you want to ask, whatever it is. Doesn't have to be for math. Next exam season, maybe. What's your first statistics and what's your first statistics and mechanics, by the way? Yeah, the stream is still going on because we're not done yet. We just finished a question. 30th is okay. 26 mech. 30th is stats. I can't do mechanics. You have to tell Alex to do that. Can I do stats? I kind of forgot about stats. It's been been a long time already. I can only do pure without reviewing. If I have to do stats, I have to review stats again. I kind of forgot like chi-square tests, Wilcoxon sign tests, all those. Rank sum. Oh yeah. These just go through the impromptu questions. I mean, impromptu questions are fine as long as I'm confident enough to do you know. No, sorry. As long as I already understand it again, it's fine. But mostly statistics is very straightforward. You know what to use already just by looking at the question. Okay, so Mr. Lennyface. Curve C has parametric equations. Find in terms of E the length of C. Sorry. So parametric equations. Mm. Okay. So just as usual, since you want to find the length, so arc length, then you have to use the formula for arc length. In this case, for parametric equation. So theta, t runs from 0 to 2. Integrate from 0 to 2. The arc length of, well, not the arc, the square root of the derivative of the squared plus the derivative of the squared. So let's do that. Derivative of x gives you e power t. Power t never dies from the derivatives. And then minus t squared. Plus, I hate this one. We have to use the product rule here. So differentiating e power half gives you 2 e power half t. T minus t. Plus, when you differentiate 4 e squared. And actually, if you see here, if I expand this here, it'll cancel with this. Is it crackling? Is it crackling? Sorry. I think it's my headset. Can you hear me properly? Yeah, it's just some mic problems. Is my voice okay now? Is my voice okay? Okay, is it my voice okay? Okay, because it has happened that my mic just can't capture my voice. So when that happens, please just tell me that you can't hear me. Okay. All right. So now that we have this, I'm raising up the mic. Now that we have this, let's just simplify a bit more. Let me just rewrite the whole thing because there's some cancellation here. Okay, some cancellation going on. Right, yeah. So now we have 2t e power half t squared dt. Okay. All right, so let's do some expansion. Let's open the squares. So e power 2t minus 2, just algebra stuff. Back when you're in secondary school. Plus 4 t squared e power t. Yeah. And notice that this guys will become 2e. Wait, no. 2t squared, e power t. And that's the key here. Right? But then this is just a square, right? It's just a square of these two terms. So e power t plus t squared this time. Just like this one, you just have to change it to a plus. dt. And now you can just integrate normally because for this range, well, this is always positive. So square root of this thing will just be that. T. And okay, you can just integrate e squared minus 1 plus 1/3 2 cubed. That's your answer. Okay, is it okay, Mr. Lenny Face? Is it okay, Mr. Lenny Face? Anything confusing? Okay. Yeah, that's for what range is that T, Alex? That's a very weird looking graph. Oh, minus 20, of course. Okay. Squiggly line in the equation box. Okay, is it okay now? Like, are you ready for your exams? Like, 2 days, in 2 days? Yeah. Actually, when you have your exams, it'll also be my exam. Windows laptop. Windows. Because I also play games. Oh, Riemann sum again. It's okay if you ask off-topic questions. It's fine. Oh, oops. Good luck for exams. Thank you. Say good. Wish them a good luck too. They're gonna have their for peer too. Mm. Mm. Yes, and everyone. There you go. All right. So let's do this question now. Diagram shows that the curve with equation 1 y is equal to 1 minus x cubed. In this case, exam question, your solutions appear. Oh, I mean, also you. Give it to you too, not just me. Yeah, the equation y is equal to 1 minus x cubed for x ranging from 0 to 1, together with a set of n rectangles of width 1 over n. Okay, so now we, just like before, we have to find the upper sum, the sum that's bigger than the integral. Sorry. So 1 minus x cubed dx. Don't solve the integral. We're not solving any integrals here. But instead, we're doing an approximation by using upper rectangles. Okay, so from the diagram, I think you can see, let me just draw it here again. Okay, bye-bye. Wait, so that means we want to find, okay, you're welcome, bye-bye. You want to find the upper rectangle? So you have to take the higher value, right? So that means look like that. Yeah, something like that. That's the idea, basically. So that means we have to take the, still want to do the recording? Okay, yeah, sure, yeah. Just keep recording it. So that means you have to take the height at the left side, right? This left height here. So this is when it's at 0, 1 over n, 2 over n, up to, well, don't take it when it's at 1, but take it at n minus 1 over n. So it should run from 0 to n minus 1 in this case. Therefore, we have the sum running from 0 to n minus 1. So just the area of the rectangles. Width is 1 over n. All of them has a width of 1 over n in this case. 1 over n. times the height. The height is when you change this x into all these numbers. So that is 1 minus k over n cubed. Hmm? Oh, so should probably use k instead. Yeah, k. This is n minus 1, k over n, like this. Yeah, okay. I keep writing capital N. Okay, there you go. Okay, so now let's solve it. Okay, so I can factor out the 1 over n out. Should be fine. And then we take the sum of these guys. 1 minus k cubed over n cubed. So first of all, this one just becomes n. There are n terms here, not n minus 1 terms. Be careful about that. We start from 0 up to n minus 1, so there's n terms. So this becomes 1 over n times, this just becomes n, minus, well, I can factor out the 1 over n cubed outside here. So what's the sum of this, of k cubed, from 0 up to n minus 1? Well, when it's at 0, then it's just 0. So you can think of it as you started from 1 up to n minus 1. And this is where you use the identity, right? The sum of cubes. So that is the square of n minus 1, n and n plus 1, so yeah, n. Square. Right, Alex? Should be. I don't have the formula sheet, so I can't remember. But I think this is, yeah, should be. Yeah, okay, thank you. Okay, so from here, let's do some simplification. This one just becomes 1. So this is 1 minus 1 over n power 4 times n minus 1 square, n square, all over 4. Okay, so 1 minus 1 over 4, n minus 1 square, all over n square. And you just simplify it, simplify, and you should be getting your answer. Okay. I leave it to you for the simplification, but I hope you get the idea. The point is, yeah, the key steps are 2n, not 3n in the numerator. Oh, okay, sorry. Yeah, 2n. Thank you. Okay, should be okay, yeah. Use a similar method to find the lower bound. The lower bound is just the lower rectangles then. I'll use blue. I'll use green. Like that. But this time, instead of taking the sum from 0 up to n minus 1, you take the right side of the rectangle. So you start from 1 up to n over n, which is just 1. So that means the lower one will be coming from 1 up to n. The width is 1 over n, so I can just put it out. They all have uniform width. And the height is just the same. Okay, cube over n cube. And you simplify this and you get your answer, okay? Just use the same identity. It's basically almost the same method. All right, bye-bye.